Our next presenter is Megha Daga. Megha is Senior Technical Marketing Manager at Cadence, and she's going to talk about how specialized processors, such as her company's Tensilica Vision C5 DSP and Vision P6 DSP, address the various performance, efficiency, and other significant challenges that are involved in enabling deep neural networks to make their way into diverse commercial and consumer products. Megha?
Thanks, Brian. Am I good? Yeah. Hello, everybody. Good morning. I'm here to talk about the neural network compilers enabling the rapid deployment of DNNs onto these specialized, low-cost, low-power devices. I'm Megha Daga, as Brian mentioned. I'm the Senior Technical Marketing Manager at Tensilica Cadence, and I look after our vision and AI processors. So with that, the agenda for today's talk for me is to just go quickly over the industry trends, which we all are seeing and which we all are aware of, and what those trends are entailing to in the software challenges, both from static offline challenges and from online challenges, and what are the solutions industries are coming onto, and some of the provisions which we at Cadence Tensilica are providing, both offline Extensa Neural Network Compiler and online using things like Android Neural Network API on our processors. So with that, neural network. Neural networks, we all know it's everywhere in every device we are using right now. My 5-year-old, she starts her day by, "Hey Siri, do this for me." My 70-year-old grandmom, she uses her Facebook app using AI. So we are seeing it in every inch of our life these days, starting from, "Hey Alexa, add so-and-so meeting for me." "Okay Google, what's the weather today?" Going to automotive. The biggest thing in the automotive industry, a huge range of vision processing moving a lot towards AI. Apps or going into navigation, retail industry, IoT, smart appliances, apps like Google Translator. This is something which I have found very efficient for me because keep traveling from region to region, can only converse in 2 languages, how to use it the best way. These come very handy. And then the AR, VR, surveillance market, and so on and so forth. So we know, we see these everywhere. So if it is everywhere, where is the processing actually happening? Till now, mostly the way it was shown was AI happening in the cloud. Most of this processing from the devices go over to the cloud, process, and comes back. But then it puts into a lot of challenges which we are facing now. First, to add latency. Latency is a big impact for, let's take example of surveillance, or let's take an example of AR/VR device, where you need to have something instantaneous. If I'm walking in a room and I'm building up something using my AR/VR, I don't want to bump into the wall. There is a lot of latency impact. We don't want to give the headache onto when we are watching through the virtual reality world. Connectivity issues, automotives. If I'm driving through a tunnel, I don't want to lose my connectivity out of a sudden and lose my ADAS controls. Connectivity is another bigger issue going into the cloud. Privacy breach, a lot of things have been going on lately on the privacy, and we want to make sure that, let's say if I'm using my home appliances or my home devices, I'm making sure my privacy stays within my home. I don't want all my conversations to be going offloaded onto the server. So privacy is another important thing, and we need to take care of breach of the privacy. And then the cost of the data centers. It's a big investment, a big cost which somebody has to take care of. So with all those things happening, where is the trend moving to? The trend is to go embedded, AI on device. And we have been seeing a lot of traction onto this, a lot of apps coming out, apps like Face ID, always on Face ID. And I have seen so much improvement over the last year itself where you lift your phone, within blimps of a second, it's getting done. It's all AI enabled. Wake word detection, they are getting better and better every day. seeing AI kind of app where you're enabling visually impaired people and making sure that apps like these can help in a huge range of markets, speech to text like I talked about. And these are just some of the examples which we are seeing, but we all know we are seeing it everywhere. So going on to device, going on embedded results into several challenges. There are things which I'm going on the mobile ask for. I want to stay in the certain limited area constraints I have. There is a power constraint I have. So I want low area, low power solution. At the same time, this neural network area, this AI field, is a very dynamically growing area. So we need something which is programmable, which is flexible. I don't want to lose that aspect of my programmability from my device. And these engines are very compute savvy. They are very memory bandwidth savvy. So we need something which is efficiently designed to work on the bandwidth requirements. We need something which is efficiently designed to give us the highest compute performance. Just putting enough MAC is not enough for me. I want something which is ground-up designed to utilize those MAC on those engines. At the same time, the latency impact, which I talked about in the previous slide, and the scalability. It's a huge market going all the way from smart sensors to data center, and there are several points in between them. So we need to take care that it's a scalable solution which we are taking care of. So the answer is something which is a specialized embedded device. It's not something which was already present and you just add certain features to it and there you go, that is your AI solution. That doesn't work anymore. You need to have something which is specialized, which has those special intrinsics, which have those special ISAs, which you can fruitfully utilize to get that edge for the AI algorithms. And some of the examples, like Brian was mentioning from Cadence, is we are providing Tensilica Vision P6, Tensilica Vision Q6, Tensilica Vision C5. There is a huge portfolio of DSPs, IPs, which we are providing, which are focused on these AI processing at different level of market. These are scalable DSPs, which we can pick and choose from based on what are the requirements, a balance of vision, a balance of AI, a higher requirement of AI. So that being said, we have come up with these specialized hardware solution. Everybody is coming up with hardware solutions or ASIC solutions, IP solutions. But when we come up with these specialized solution, that takes us to this different challenge of software. So okay, you solve this aspect, but how can I make now my software, my networks work on this? I was so used to working on my CPUs, GPUs of the world. How do I get to my embedded platform? So there are all these challenges of being specialized engines. Specialized engines means those specialized ISAs underneath. So to get the most optimum result, you should be capable of using those specialized ISAs. The market need, it's evolving. Every now and then, every month from now, we see a new layer coming up, some kind of a new network which is coming into deployment, layers which were no longer into existing. For example, from an year back, if I take an example, depth-wise convolution, which was not there before. MobileNet came with it, and it was just a blast in itself, and everybody wanted MobileNet. So we need something which is able to come in speed as the market is coming in speed. There is a fast need of deployment. The turnover we have seen with the mobile production, it's very high in this current decade which we are looking into. So we need the software also to be capable to keep up with that change. At the same time, we need a solution which can give us the most optimum result. We talked about the hardware resources to get the most compute benefits and the memory bandwidth benefits. We need the software to make sure that it is able to utilize those things. So these are different challenges, and where it goes to is a solution where we are looking into some kind of an automated code generation tool for NN. I look into this and split it into two ways. There is an offline support and there is online support. Offline are, and I'll talk one by one on each, offline supports are mostly where we pre-know our algorithm. If I am working in automotive industry or I'm in the AR/VR industry, I know what I'm going to deploy. There is a pre-hand knowledge of the network I'm going to put onto my engine. I have pre-trained it. So I as well used a tool, a compiler, which can get the most optimum result. I am not so much concerned about the time it might take to come up with the output. Obviously, I don't want to sit for days over there, but it doesn't matter if it is an hour or so. So we need an offline solution which can get me the most optimum code generation for that specific engine sitting in my device. And one such example is the Tensilica Extensor Neural Network Compiler, which I'll be talking further on. Moving on to online. Online is something which is, this is an app development age. So everybody who has a mobile phone, the app developers may want to put something of their own customization into it. I might want to have an app where I just want to browse through my pictures and pick on certain things and find certain criterias out of that, and I build my own thing. So how do we make easy deployment of those apps? We need something dynamic. They don't want to go into the intricate details. They cannot go back and do something offline and come back again and put a binary. And for that, we have examples of things like what Google came out, Android Neural Network API, where on top you just give your framework and it will get deployed on the engine. And I'll go more into detail about the support of things which is going on. So going into Extensor Neural Network Compiler. This is something Cadence Tensilica has been supporting since last year. We started with our Vision P6 processor, then Vision C5, and now Vision Q6. So as our processors are going, it's a tool which is staying common on top of all of them. So we are making sure that it's a centralized tool which you use on all of them. You don't have to deviate or don't have to migrate from one thing to the other. The job of this tool is to take a trained network, a floating point trained network to start with. This can be defined in different frameworks, be it Caffe, be it TensorFlow, and so on and so forth. It will take it, it will go through a black box for the customer where it's doing two steps. It's going through an analyzer where it's doing a quantization. We efficiently do our 8-bit processing, and we want to make sure that we are able to utilize it to the fullest. So this quantizer's job is to convert those floating point weights into 8-bit quantization of both data and weights. And once the quantization is done, we need to make sure that the accuracy loss is within a certain % to where I started from. So that is a job which this tool does. It does that quantization. Once the quantization is done, it will go into the optimization, and optimization has several folds into it. It will utilize manually optimized CNN library where we have several functions sitting in there, hundreds of functions specific to neural networks sitting in there. It will pick the most optimum solution for a given layer, for a specific kernel, for a specific spatial dimension. It will do tile management, DMA management. So this tool has all the knowledge of what kind of memory you are using, the local memory you're using, what kind of DDR latencies you're going to face in the system. Based on all that, it will do the DMA management. It does kernel fusion. It does some kind of reduction removal, and so on and so forth, and come out with a source code. So here's the beauty. The customer has the source code. Source code is viewable. The customer can take that source code onto our instruction set simulator. They can profile it. They can debug it. They can change it, modify it the way they want to do it. And then, if needed, create a binary and deploy it, which I'll go in further. So going into highlights of this. The first step, quantization, is what I talked about initially. And this is where we are very proud to say that we have come up with our own custom quantization mechanism such that we are able to stay within 1% of the accuracy error loss. And here I'm showing several classification networks which we have ran through our tool. And we are showing that for top 1 error and for top 5 error, we are staying less than 1% and less than 0.5% respectively. So there is a lot of custom effort which goes into that. There is a lot of knowledge base which goes into that. And this is one of the crust of the tools to come out with. Second thing, not to forget, is the optimization. we need to make sure that what we are getting from the software tool is able to utilize the crust of the hardware, which is what we are able to see over here. If we look at these networks, then let's say the ResNet 50 MobileNet, one is basically the most optimum solution if somebody goes and start manually coding and optimize using the intrinsics and everything. And the green bars are showing what we are achieving through our tool. So we can see that we are very close to what you are getting manually. So we are getting the most out of our tool, and we are able to get that optimization. So very close to what a market deployed solution would be, and it takes you, it does that speedy effort into the time to market. All that being said, there is a continuous improvement which needs to go in these tools. They need to adapt, and that's where a lot of things helps us. It's a software stuff which we can keep updating, which we can keep adding. But to add to that, we have a hardware which is very flexible, programmable. So our hardware can also support whatever the software is going to deploy. So we are continuously looking into the optimizations. For example, when we look at our last generation of XNNC, compare it to the previous generation of XNNC, we went through several profiling, and we see where to highlight, what to look into more. And we found certain sockets, worked on those certain sockets, improved those as shown in these chart, and made sure that we are further and further improving the overall network performance from the tool. At the same time, we are continuously working on adding these new layers, the exchange formats coming into picture, the frameworks, the features, and those are the things that is a continuous addition with what we already have and things which we'll be adding. Things like custom layer. This is something which is very important to customers because none of these standard networks go directly into the deployment. Most of the time, customers add their own flavors, their own structure to the network when they're going into deployment. So we need to have something, a very simple way for customers to use and add their own proprietary stuff, their own flavor to the network, and that is what we enable through our custom layer. We also understand sparsity is something which is very well there in most of these networks, so how to best utilize it through our tools. And these are all the things which are continuously getting added to XNNC. So that was all about how we can generate the code, efficient code generation through the tool, but the next step to that is the time to market. How do you finally take this generated code onto a real ASIC and show the performance? And that is what the chart shows. If I look at the first two bullets, this is basically at the customer end, taking a network, training it, doing any kind of pruning which is needed, sparsity generation, and so on and so forth. Once that is done, it goes through the next two bullets of profiling and optimization using the XNNC like I talked about and the NN library. Now, once I have the code, I have looked through it, and I'm satisfied with it, I can basically just create a binary out of it and deploy it onto a real platform. And here we have done experiments, and I will show some of them, where we do the platform level integration. So we have SDKs, we have NN frameworks, we deploy them onto that, and then it goes through a verification and a validation process, and we make sure that in field it works as we expected it to work at the architectural design level. And one such example, what we are showcasing right now in our demos also is this particular MobileNet V1, which we took a trained TensorFlow model, and we went through the XNNC, which generated a quantized, 8-bit quantized, optimized code. This source code was then converted into binary and went through the integration process on putting it onto a Dreamchip SDK. Dreamchip is a third-party platform which can be used for evaluation prototyping purposes. It has quad P6 sitting on there. So we just took one of them, put it onto just one of the P6 platforms, verified and validated, and everything, all this process can be done end-to-end in less than a couple days. And here you have a runtime framework which is running on a real ASIC platform. So it really speeds up your time to market process, and that's where the software comes a lot more handy. So that was mostly about the offline. Now to touch a little bit on the online, the dynamic part of the deployment. This is where I would like to highlight the Android Neural Network API, which is something which we again support on our Vision P6 processors. Android Neural Network API is a way for an easy deployment of these neural networks onto Android platforms. What they have done is, at the top level, for an app developer, all he's doing is, here is my network, go and deploy it. What the internals will do is, it will call a specific net framework, or it will call specific ML libraries and go into the runtime. Runtime is where it is the most intelligent stuff is happening of decision making on where I need to go, where I need to split the processing between the DSP, specialized engines, the GPU, so on and so forth. On each of these engines, there are device drivers which are sitting, which are responsible to communicate with the HAL layer, and there's a questionnaire which is going on what I can support, what I can do, how well I can support, and based on that, it will get supported through the Android runtime and through the DSP. So this whole process has enabled the app development on Android devices. It has enabled those apps to directly use the underneath lying specialized engines and get the most efficient PPA solution for them. And to highlight what at the Tensilica level we have done is, we have a Tensilica Vision P6 DSP where we are running all these Android NN API frameworks, and we have done it to a level where you can go as low as a kernel level at a layer level, or it can be subgraphs, or it can be a complete graph. We also make sure at DSP driver HAL level that we are able to do the most optimum tile and DMA management with a lot of data rearrangement as needed for the layer. These are separate hand-optimized libraries which are very specific to neural network definitions provided by the Android Neural Network API. They have their custom quantization mechanism, making sure there is accuracy from the implementation and so on and so forth is being taken care of by the Vision P6 implementation. So with that, concluding on what I was saying, there is a trend which we all are seeing that all this is getting deployed towards the on-device AI. But with that, we see a need for the software to speed up our time to market deployment, be it on the offline side, be it on the static dynamic side. And I went through certain examples of Extensa Neural Network API, which is enabling your static offline compilation, and Android Neural Network API enabling your dynamic deployment process, and all that getting supported through our Vision P6 C5Q6 DSPs. For more information, I will gladly say come to our booth at 200, see our demos. We can walk you through that specific thing, the XNNC deployment process, which I just talked about. We are showcasing that. And with that, here are some of the links where you can go and get some more information. Thank you.
Good job, Megha. Another presentation that finished on time. Yeah. We're on a roll. I just want to point out to your attention the microphone at the center of the room here for any comments or questions that you have. Go ahead.
Hi, thank you for your speech. And I have a quick question about that, the Extensa compiler, and after that you said that it's just optimization of the source code, and after that there is a library, right? So it's like operators kind of things. Is that the compiler is directly generating the binary code of that DSP, or still needs to have different, operators or layers to actually, do that?
So the compiler is basically generating a source code for you, an optimized source code, which is using the intrinsics, underlying intrinsics. So you don't have to do any other thing on top of that. You can basically just take that source code, run it through our compiler tool, and create a binary and deploy it. Okay. There is no additional layer on top of that.
I see. So, and you also mentioned that how many operators are currently support? Is that because we see that a lot of algorithms, they have different type of operators, and we see that as a limitation at this point, that as the developers would like to use?
Yeah, so as I mentioned, our library, it's a very rich sets of hundreds, more than 300 of NN functions. So
300.
let's say if you have more than that. So let's say if you have a 3x3 function you're looking at, we might have 7 to 8 different variants for just a 3x3 kernel, because we understand there is a need for, there are different spatial dimensions, there are different depth dimensions, and you might want to use a different vectorization scheme for a given layer. And all that we take care of in our NN library suite.
Okay.
So you have a huge range of things to pick and choose from.
So, sorry, one last question is about customize the layers. You also mentioned that you can support the customized layer. Is that in addition to the 300
Yes.
layers you already have? Is
Yes.
That, okay.
So custom layer is something which is, customer driven. So it's
Yeah.
a customer who will put their own flavor onto it. So for us, we are providing a placeholder, an easy way for customers to come and integrate their things into our neural network chain.
Is there any performance penalties compared to the native operators you already created, or it's like a
No, I
same
mean,
way, right? Yeah.
you can basically define a custom layer using the intrinsics, and you can get the most optimum fixed point results out of it. There is no limitation onto how you should define a custom layer.
So it will be like a register as the native operators and run through the same
Yes.
pipeline as that.
And to our customers, even our libraries are open source. So
okay.
let's say if they find something which is very close to a library, but it's their own flavor which doesn't exist as a standard, they can always use our library source code and get it from there on how their implementation should be.
I see. Thank you very much.
Sure.
Thank you.
Thanks for all your excellent questions. Any other comments or questions from the audience? Okay, it's break time again. Thank you very much, Megha.
Thank you, Brian.